Hey guys, today we're going to learn about section 5.1, which is graphing a system of equations and solving. So before we begin, go to slide number 5, and we're going to look at the visual representation of what we're doing today. So slide number 5 shows 3 cases of solving a system. So a system for this class and for these sections deals with 2 equations that basically work together. They have a solution together. So if we look at the 3 different cases that you might get, you might have 2 lines that intersect. And in that case, the solution is just the point at which they touch each other, where they intersect. So we would say there's one solution there, whatever that coordinate is, x comma y. If the lines are parallel, that means they never intersect. So in this case, we would say there's no solution. And in the last case, we have coinciding lines. So we are going to say coinciding lines for this class are 2 lines that are right on top of each other. They're literally the same exact equation. So if they're the same exact equation, they're touching every single point together. They're intersecting at every point of the line. So in that case, we're going to say infinitely many solutions. Usually we'll say all real numbers. For graphs we say, and systems we say infinitely many solutions. So now let's look at the algebra for these types of problems. Before we begin, we're going to look at specific coordinates, and we're going to find out if one of those coordinates is a solution to the system. So we're going to do letter A, and you guys will do B on your own and check your answer. So in order to find out if a coordinate is a solution to a system, you want to plug in x for x in the first equation and y for y in the first equation, and check if the solution or the equation has a true statement. And you'll do the same thing for the second equation. And both equation 1 and equation 2 have to have true statements in the end. So for the first one, 2 plus 5 equals 7. 2 plus 5 is 7, so 7 equals 7, and that works out nicely. That's a true statement. In the second one, we have 2 times x, or 2 times 2, minus 3 times y, or 3 times 5, is equal to negative 11. When you simplify, that's 4 minus 15, which is negative 11, equals negative 11. So this is also a true statement, and therefore 2, 5 is a solution to the system. Now we're going to be going backwards in a moment, where we actually have to find the solution algebraically. Today we're actually doing it by graphing. Go ahead and try B before we move on. Alright, so when you guys plugged in x and y, you should have gotten that the first equation gives you a true statement, but the second equation, 0 equals 2, is false. And therefore, negative 2, 0 is not a solution. So now we're going to go over the steps to solving a system of linear equations by graphing. So go ahead and write these steps down, and then we'll discuss them. So in these steps, step 1, it says graph the equation in the same coordinate plane. So graph those 2 lines in the same coordinate plane. I'm going to add, make sure y is alone if you're using slope-intercept form to graph, meaning the slope and the y-intercept. 2, estimate the point of intersection. Where are they touching each other? And 3, check the point from step 2 by substituting x and y in for both equations. So this is like your check. This, I'm going to say, if you have time on a quiz or test, you should do that step, and I'll show you how. So here's problem 1. We're going to need some graph paper, so let me just view paper style. Perfect. Okay. Equation 1. The slope and the y-intercept. So first check that y is alone, which it is for both. So we can go ahead and say equation 1 slope is equal to negative 2, it's the number in front of x, or negative 2 over 1. and the y-intercept b is 5. So when I graph that line, I have 5 on the y, 1, 2, 3, 4, 5. That's my starting point, b beginning value, and my slope is rise over run, down 2, right 1, down 2, right 1, or up 2, left 1. And there is my, equation of the line. Have arrows on that line. Equation 2 gets graphed on the same coordinate plane. The slope for equation 2 is 4. The y-intercept is -1. So I start at -1 on the y, which is right here. My slope is 4, or 4 over 1, which means I can either go up 4, right 1, up 4, right 1, or down 4, left 1. And when I graph that, they both intersect at this coordinate, and that coordinate is +1, 3. So in this, you can write x equals 1, y equals 3. This is totally perfect, just the coordinate. This is what I want. So you need a coordinate. Even if you say this, you still need a coordinate. That's the solution to the system. And if you wanted to check, you would do the same thing we did in the problem where it asked you if the coordinate is the solution, where you plug 1 into x, you plug 3 into y, and you check if it's a true statement for both equations. Okay, let's go ahead and do, I'll have you guys actually try number 1, and then I'll show you what to do with number 2. All right, so you guys should have graphed these lines. The one in green is my second equation, the one in pink is my first. And you should have noticed that the two lines intersect at 0, 3. So that is your solution to problem number 1. Okay. For problem 2, now you can choose to graph this with your intercepts, or you can get y alone. So remember, you have two methods to graph for a reason. You can find the x and y intercept for both problems and graph using those. But it might just be easier, since we've just done a bunch of slope and y-intercept problems, you can just go ahead and get y alone. So in this problem, if we subtract 2x from both sides, we get y equals -2x plus 5. That means that our slope, m, is -2 over 1, and our y-intercept, b, is 5, or 0, 5. So when I graph that part of the equation, I start my graph at 5, and my slope, rise, is -2, down 2, right 1. Down 2, right 1, or up 2, left 1. And now our second equation, in order to get y alone, we subtract 3x from both sides. We get -2y equals, always write that x term first, so -3x plus 4. Divide both or all terms by -2 in order to get the y alone. And we get y is equal to, careful here, -3 over -2 is +3/2 x, and then 4 divided by -2 is -2. My slope is 3/2. My b value, or y-intercept, is -2. And so when I graph that, I have a point on -2. And my slope, rise 3, run 2. Rise 3, run 2. And there's my equation. So my final answer would be where the two lines intersect, which is 2, 1. So for the rest of this, we're just going to do this word problem right here together, and the last one we'll save as a warm-up. So this problem says a roofing contractor buys 30 bundles of shingles and 4 rolls of roofing for a total cost of $1,040. In the second purchase at the same prices, the contractor buys 8 bundles of shingles, and I'll do that in green actually again, for $256. Find the price per bundle of shingles and the price per roll of roofing paper. All right, so we're actually just going to set up for this problem. And then I'll have you guys kind of graph it on your own and check for your answer. So let's write the equations down. So step 1, set up your brackets to remind yourself we're setting up a system here to solve this problem. Then define your variables. We know in a system we have a variable x and a variable y. 2 variables, 2 different things in the problem. The question at the end of the problem tells you what those variables are. Find the price per bundle of shingles and price per roll of roofing paper. So my variables would be, let x equal the cost for a bundle of shingles, and let's let y equal the cost for a bundle of roofing paper. Now, they always give you 2 statements in this problem, and usually that gives you the equation. So this says that a roofing contractor buys 30 bundles of shingles, 4 rolls of roofing, and the total is $1,040. So I'm going to pay for every bundle of shingles, meaning it's 30 bundles of shingles times the price, which we said was X, plus 4 rolls of roofing times the price, which is Y. For example, if roofing was $2 per bundle, we would say 4 rolls is $8, 4 times 2. And the total cost is $1,040. Then they give you more information. They say the contractor buys 8 bundles of shingles on another purchase for $256. But it doesn't say anything about the roofing, so there's not going to be a Y in this equation. It's going to be the 8 bundles of shingles times the price for shingles, which is X, is equal to $256. So we're not going to graph this one for the sake of the length of the video. We can go over it in class or do another word problem together in class. But the end result for all of these problems is to do the same process you would if it wasn't a word problem. You want to graph the system, just like we have been doing, and then look at where the solution is. So let's just say you got 2, 3 as a solution. This is not correct. If it were a solution, you can say that X, the cost of shingles, would be $2, and Y, the cost of roofing, would be $3 per bundle. So again, this one was just a setup, and we'll go over more types of word problems in class, right?